All right, hi everyone. Today what we're going to do is we're going to go through completing the square again. We're going to change it from our standard form, our x squared, to our completed the square form, okay? So that's what we're going to do today. So let's go ahead and look at some problems. So if we start back and we say, what are we doing? We're changing something from this ax squared plus bx plus c, and this is just some x squared problem, okay? And we're changing that into our nice vertex form. This is what we call standard form. Okay, standard, everything is on one side. And then we can change it to our complete the square form, which is a x minus h squared plus k. Having this form on the right allows me to graph, because we said our vertex, our center of our graph, is comprised of these two letters h and k. H and k. And if I know where h and k is, we know where the center of the graph is. That's h or k. And then the a value here tells you, the a value tells us how wide our graph is. Is it going to be wide or narrow? Okay. So if we can get into this this vertex form, we can graph it quite easy. Okay? It takes a lot of work away from us having to do a t-table here. Okay, so let's look at our first question here as we practice through these types of problems. It's going to be y is equal to x squared plus 18x plus 89. Now, hopefully, you guys went through your Excel problems and you guys started to build the pattern. And so we're going to go ahead and practice this again. Whenever we're completing the square, I'm just going to bubble up. Okay, this is level 1 problem. I'm just going to bubble up. Now, what goes in that bubble? What goes in that parentheses? Remember, a perfect square is a term like x plus 2 squared is x squared plus 4x plus 4. X plus 3 squared is x squared plus 6x plus 9. So these perfect square forms are rare. They're not very common, but there's special ones, like what's 2 squared, what's 4 squared, what's 3 squared. And there's a pattern. The b value is always half to complete the square. It's always half to complete the square. So we said we're just going to cut this in half. What's half of 18? Hopefully you see half of 18 is 9. And then what is the square of that value? 2 squared is 4, 3 squared is 9. The square of 9 is 81. I don't have 81 here. So the way I taught this last time is I went ahead and I wrote 81. If I add 81, I need a minus 81. So we have a nice perfect square here, x squared plus 18x plus 81. So I don't need to memorize all the perfect squares in the known universe, but I can generate them. We have our leftovers here. We're going to combine those downward. Negative 81 plus 89 is positive 9. Oh, sorry, positive 8 is counted. So for this graph here, we're all good to go. Vertex form says our a value is 1. Our h and k is negative 9 and 8. Why is it negative, Mr. Ko? Is because if you remember, the standard form is x minus h. The negative is already permanently stuck there. So a negative and negative would force that to be a positive 9. And if I put a negative there, x minus negative 9, that would become a plus 9, right? Okay, so that's why we do that. And we can graph this in a matter of moments. If I can get to negative 9, let's say this is negative 9, and this is negative 8. One space over, one space up, one space over, one space up. The reason why we can say that is because my a value is 1. That kind of gives me a hint about how many spaces up. And we have our parabola. Now, just on the side note, if my a value was 2, one space over would mean 2 spaces up. One space over means 2 spaces up. And this graph would be more narrow. If this was a is equal to 3, one space over would be 1, 2, 3 spaces up. One space over means 1, 2, 3 spaces up. So it's an easy way for us to graph these parabolas using this simple rule. The a tells me how much faster. It's a multiplier. It's multiplying my graph. So if your paycheck is double times 2, you're going to make more money. If it's triple, you're going to make even more money. But if it's half, what if you did something bad and your allowance is half? It means you're going to make money slowly. And very similar thing when it comes to gaming. If you're playing a game and you get to use a token or an item which allows you to double your experience, you start to grow really quickly. But if you have some type of status and slows down your experience growth, right, it slows you down. Okay, just on the side. Okay, so from here we went and talked about negative problems. What if there's a negative in front? Well, we can do the same exact problem that we looked at here, and I'm going to spin this around. So I'm going to say y is equal to negative x squared, let's say minus 18x. I'm going to give myself a third number. Say it's going to be plus, no, let's do minus. Let's do minus 82, okay? So you can see here that this doesn't follow our simple x squared scheme. Means if I was a good little boy, right, and there was nothing there, easy problem. But because we have a negative now, it's going to change it, and we're going to call this level 2 problem now. So we cannot complete the square with any number in the front. We cannot, right? It's like your mom can't have friends over if you have a messy house. You got to clean up. So we're going to clean this up first. And the way we do that is we ask the negative to leave by factoring. We're going to take out the negative from both the front two terms. So we're going to take out a negative and take out the negative. But if I take out a negative from each, we factor it out. We end up with a positive and a positive. And I am not going to take out the negative from the back. That's just the way I teach this. This is the way I do it. I find it's easier because when we do our next level problems, I don't want you guys to end up with fractions too early. And in many cases, we don't have to end up with fractions if we do it this way. Okay, so now that I'm here, please look at the inside problem now. Now we are good to go. Now we're back to a level 1 problem. The negative is in the front and we can worry about it later, but we were able to get rid of that negative sign so we have a simple x squared again. We're back to easy street, okay? And that is the reason why we get rid of that negative or whatever number that may be there. We clean it up, stick it outside, and we'll worry about it later. The same way you guys clean your room. Throw everything in the closet, underneath your bed, we'll worry about it later. Now, I just want to make sure you guys double check this real quick. Is a negative times a positive is a negative, and a negative times a positive is negative. So we didn't lose the sign, we just moved it out. Okay. And that's something you want to double check, please. Every time you do these problems, just make sure you didn't mess up that simple step. So our next step here, let's rewrite this, and we are now going to bubble up. We can now bubble up easy, freely. So we always divide the middle by 2. Always cut that in half. X plus, what do you think that's going to be? 9, right? If you guys want to participate, you guys are free to definitely type it in the chat. Okay. And what's a perfect square? 9 squared, right? That should be 81. Do you guys see an 81 anywhere? So I'm going to write plus 81 and minus 81. And this is what we did yesterday in class. And please notice I keep those inside the parentheses, because this is its own little world right now. We're playing in our own little world and we'll worry about the outside later. Because we have our perfect square now. Please take a look. We have x squared plus 18x plus 81. That is a perfect square for us. Now, normally we now have to combine this 81 with the 82 on the outside, right? He wants to go out and play. We did the same thing up here where we combined our leftover values, except one is inside the parentheses and one is outside the parentheses. And here's a simple trick. I told you this is a story about when you want to play outside, you got to put on a jacket. Check it out. This is the jacket. We have put on the negative sign. Negative times negative 81 is a positive 81. So see, we kick it out and now it becomes a positive. We can combine those two numbers now. Positive 81 minus 82 is a negative 1. So we are still able to complete the square. Thank you, good job. We're able to complete the square with just a little extra step here, even though there's a number in front. So we do it with an extra step here. Okay. So that's our negative version. So we've now covered everything we learned yesterday. We covered everything we learned yesterday. Now I'm gonna make this problem our next level problem, which is still this negative level problem, okay? Except I'm gonna give you guys a number now. So here is our next type of problem. And it's y is equal to 3x squared minus 48x plus 184. Oh my gosh, number's so big. Can you guys tell me which number do you wish wasn't here? The 3, the 48, or the 184? Which of these numbers do you wish that wasn't here? Thank you. So I heard some of you guys are responding already. Yeah, I wish. So you guys are, I'm seeing a lot of people call different numbers here. I only care about this front number. Why? If this wasn't here, this would have been an easy problem. Remember, x squareds are the easy problem. Anything else is going to make it hard. So here is my problem. Just like the negative here, if negative wasn't here, this would have been an easy problem. It'd just be x squared. So our rule is this. If there's an a in the front, we can't have the a value. No a values. A is not 1. We want it. We want, oh, that's the W. We want, oh my gosh, want a to be 1. We want this, okay? We are super happy if a is equal to 1. That becomes a level 1 problem. The 184 is a big number. Sure, I see that. The 48, how's that going to help us? But the biggest deal is I don't want the a value. No a value. Because if it wasn't there, this would be a level 1 problem again. So this is how we get rid of it. We're going to factor the 3 from the first 2 terms. So we're going to divide 3 to both of them. 3 divided by 3 and 48 divided by 3. Because I'm factoring it out. We're left with x squared and 48 divided by 3. If you guys can't divide it, if you guys aren't good with division, I'm going to show you guys how to divide without writing anything special, okay? How many times does 4 go into, sorry, how many times does 3 go into 4? Exactly once, remainder 1. How many times does 3 go into 18? That is 6 times. Okay, let me show you guys how I divided there, okay? Again, 48 divided by 3. How many times does 4 go into 3? 1 time, remainder 1. I guess, okay, 4 goes into 3, 1 time, remainder 1. Now this is not 8, this is actually 18 now. How many times does 3 go into 18? 6. Like, no joke, that's long division. Let me give you another one, okay, just for show. 6, 5, and 1, okay? Divide by 3. How many times does 3 go into 6? 2, no remainder. How many times does 3 go into 5? Only once with a remainder of 2, right? 3 goes into 5 1 time, remainder 2. And then how many times does 3 go into 21? 7. We can divide this in literally 1 line. Like, I'm not kidding. This is us doing long division. If I say 7, 5, and 3, okay? 7, 5, 3, divided by 3. Okay, let's see if this is divisible. How many times does 3 go into 7? 2 times, remainder 1. Now it's 15. See, that's 15 now. How many times does 3 go into 15? 5 times, good job. No remainder. How many times does 3 go into 3? 1 time, we're done. That's it. That's us dividing, long division, like no joke. Okay, let's go back to actually the lesson today, okay? So 184. Now let me make sure this is the same problem. I didn't not include stuff. 3 times x squared is 3x squared. 3 times 16 is 48. So we still have the problem, except I was able to get rid of the x squared. So then 3 in front of the x squared to make this a level 1 problem again. So from here, we go ahead and we bubble up. What would be in the bubble? X minus what? X minus 4, x minus 16, x minus what? What are we going to get here? We always divide the middle by 2. So what number will it be inside the box? Or inside the parabola? X minus what? What do you guys think? So we took 48, we got rid of the 3, we're left with 16. And then from here, we just follow our rules that we did before. We just divide it by 2. That's it. This is actually it. X squared minus 16x is x minus 8. What's the perfect C I wish I had? 8 times 8 is positive 64. if I add 64 and minus 64. Okay, so take a look here. We have our perfect square, x squared minus 16x plus 64. That's my perfect square here. Now what happens next is we have to let you out and play. We're going to go out and play here. Oh, that looks terrible. You're going to get to play with this guy, but how is 64 going to combine with 184? Well, remember, isn't 64 inside the parentheses? It's inside the house. You guys ever watched The Martian with Matt Damon? Every time he would have to be able to leave, he would have to put on his spacesuit because you can't walk out, apparently, at Mars. You would suffocate to death, right? So we're going to put our spacesuit, we're going to put on our jacket, we're going to put on our, take our umbrella with us. So 3 times 64, negative 64 is going to be negative. 3 times 60 is 180, and 3 times 4 is, let's write it out. 3 times 64 is 12, and 180, okay, is 192. So we're going to say it's going to be negative 192. Okay, we're almost there. 192 and 84 combine to become a negative 8. So now that we have this new vertex form, I can tell you that the vertex is at 8 comma negative 8, right? Remember how that's negative? And then we also know the graph is 3 times as fast. So if I try graphing this, 8 is 1, 8, let's say over here, negative 8 is down here. Here's my graph. One space over, I'm going to go 1, 2, 3. One space over, 1, 2, 3. It's going to be this really skinny graph because this graph is making a lot of money. 3 times the amount. Let's practice this again. We're going to give ourselves 2 different numbers. And we're going to do those 2 problems at the same time, okay? Okay, I'm going to try to give myself a quick example. This one looks really big, but we'll do it. Okay, we'll do this. Okay, my problem is, here we go. We're going to do 2 problems at the same time like we normally did, just to practice this out to see the steps. Y is equal to negative 3, sorry, that's not negative. Let's do positive 3x. 3x squared plus 30x plus 78. That's my first problem. The second problem is going to be a little more bigger. Y is equal to 7x squared minus 98x plus 339. Okay, 2 big problems. Now, my first question to you, looking at my first question here, my first problem on my left, what number do I wish wasn't there? If it wasn't there, this would have been an easy problem. What number do I wish I wasn't there? The 3, 30, or 78? Thank you very much. I wish the 3 wasn't here. On the right side, what number do I wish wasn't there? The 7, the 98, or 339? 7, thank you, very good. Right, so these are numbers we don't want. Because if it wasn't there, we would be able to do completing the square in 1 line. Remember, this was a 1-line problem. Completing the square was a 1-line problem. That was 1 line. So fine, for us to set up, if you guys ever cooked before, it's always nice to make everything, all the vegetables are chopped, everything's prepped, good to go, so you can just start cooking. So we need to prep this because I don't want the 3. So first step we do, we get rid of that 3. 3 leaves, we are left with x squared. Remember, we're going to take the 3 from both these first 2 terms. The 78 is not going to be left because I can divide 3 by 70 anyways. And the reason why I have kids not take the 3 from the last number is because I don't want to write a fraction. And 99.9% of the time, you always end up writing a fraction there. So I don't want to do that. So trust me, leave it out so you don't have to deal with the fraction. And then 30 divided by 3 is left over 10. I want you guys to be okay with this. 3 times x squared is 3x squared, and 3 times 10 is 30. We end up with the same exact problem here. I'm just setting up. If I cut an onion, it's still an onion, it's just in pieces. I'm just prepping the work. On the right side, we don't want the 7, so let's get rid of the 7. If I get rid of the 7, we end up with y is equal to 7 parentheses. What's left over inside that parentheses? Remember, I don't divide this by 7 because if I do, I might end up with a fraction and I'm too lazy for that. And hopefully you guys will follow suit. On your homework today, I need you guys to show all these steps out. You will get credit, not for just getting the answer, but showing the work, showing the steps that I've been teaching, okay? Here we go. So what's inside? If I take away the 7, we have x squared by itself, and 98 divided by 7. Let's see if we can do that. Let's see if we can do that without using the calculator. How many times does 7 go into 9? Exactly 1 time. Good job. Remainder 2. Right? 7 goes into 9 1 time, remainder 2. 9 minus 7 is 2. How many times does 7 go into 28 now? 4. And that is us dividing. Okay. I didn't know 98 divided by 7 is 14. I didn't, but I just did the work. And we have our little space here. We have a little gap here. Okay. All right. Now that we're prepped to go, see, now we have a nice x squared problem. We can now complete the square. Let's go ahead and do our next step. Y is equal to, we're going to do 3 squared, 7 squared. All right, now we bubble up. What goes inside the first bubble on my left? What goes inside this bubble? Remember, we always divide by 2. Hopefully you'll say 10 divided by 2 is 5. Perfect, you got it. On the right side, I have 14. Fine, what's half of 14? We can do that. X minus 14 divided by 2 is 7. Good job. Okay, so now we have our vertex. So we're almost there, right? Now we have to clean up the rest. The perfect square, 5 squared is 25. I don't see 25 on the board. That's why I need to write 25 myself. If I add 25, I need a minus 25. On the right side, I need 7 squared. I don't have 7 squared on here. I don't have 49. If I add 49, I need a minus 49. So take a look. The process is exactly the same here for both these problems. We have our nice perfect square. I always like pointing that out. X squared plus 10x plus 25. Oh, that's a beautiful perfect square. X squared minus 14 plus 49. That's a nice perfect square. Perfect. Now we have to deal with our overspending, and these guys are going to have to hang out. Now, how can I get 25 to talk to 78? 25 is inside the house, right? It's inside the parentheses. So we can multiply it to kick it out. Put on your jacket, put on that 3. 25 times 3 is 75. So we end up with negative 75 here, right? That's what happens here. On the right side, that's a bigger number. That's a bigger number. 7 times 49, that's a huge number. If I don't know what it is. 49 times 7. 9 times 7 is 63. And 4 times 7 is 28 plus 6. 28 plus 6 is 34. Right? 28 plus 6 is 34. So it's 343. So we end up with negative 343. Oh, you got it. Good job. Wow. Thanks. Thanks for double checking. And now we can combine those. Okay, let's combine these. 75 and 78, right? How did it become 75? Remember, it was 25 on the inside. But on the outside, people think, oh man, that guy's a star. It's 75. Some of you guys, when you guys are at home, you guys are treated like little babies. But in the real world, people think like, oh yeah, you're an adult almost. Okay, maybe you're like a 14-year-old, never mind. So plus 3 on my left. And on the right side, how do I get from negative 433 plus 339? In my brain, I actually cheat. Like the way I count, I say, hey, if I add plus 1, is that 40? And then 40 to get to 43 is plus another 3. That's going to be a negative 4. Okay. That's how I do math. I'm sorry. I can't minus 43 from 39 in my head. Maybe you can. But for me, I just say, hey, 39 to become 40 is 1, and then another 3 more. So these are our 2 problems. We're all set up, good to go. We can now declare what the vertex is. It's negative 5, 3. The vertex here is 7, negative 4. Remember, the sign switch for the h values. Not only can we find the vertex, this is also the line of symmetry. This is also, since the parabola is going up, this is also the lowest point. Tells us a lot of things without having to deal with this guy. Imagine if you had to do a table for 7x squared minus 9x plus 339. Imagine if you had to do a table for it. I'm going to go ahead and just do 1 for you. If I say x and y, okay, just 1. I'm just going to do 1 so you guys will realize how terrible it is. If I plug in 1, that's 7 times 1 minus 98 times 1 plus 339. How much work would that be? What if I stuck in 2? 2 minus 98, 2 plus 339. I need a calculator for this. And not only the problem is the vertex isn't till 7. We're not going to even see the center of the graph till 7. I'm way off. I barely started at 1. I would never have found it. I never found where that vertex was. Okay, so let's go ahead and do this one more time. Let's see if you guys kind of got the rhythm to this now. Okay, let's see if you guys got the rhythm. Now, I want to make this a negative. Make it just a little bit different. Here we go. Y is equal to negative 2x squared plus 16x minus 38. What number do we wish was not here? The negative 2, the positive 16, or the negative 38? Thank you. Some of you guys are telling me a negative 2. Right, so let's get rid of the negative 2. Y is equal to negative 2. Now, when I divide everyone by negative 2, okay, I mean, not everyone, but like the first two numbers, what happens? The 2's give me x squared. And what's 16 divided by negative 2? That's going to be negative 8x. Now, if you're not sure, good job. If you're not sure, double check. Negative 2 times x squared is negative 2x, and negative is a positive 2 times 8 is 16. 2 times 8 is 16. So we're there. And when we got rid of the negative 2, this is now a super easy problem. Let's go ahead and bubble up. Y is equal to negative 2. Can you guys bubble up for me? And let's see what number you guys can get. What do we do with the middle term always? We divide it by what? Go ahead, if you can get it right on your paper, make sure you're there. If you can move on and finish it, great job. I'm going to walk you guys through it again. It's x minus 4. That's our perfect square. So what's the c value we need to make this perfect square happen? 4 times 4 is 16. So I'm going to write plus 16 minus 16, right? Because you can't just come up with numbers. So if I borrow 16, I need to pay it back with another 16. Now here's our next trick. We need to combine 16 with the 32, but that's not, remember, 16 inside the house is not 16 on the outside of the house. This guy's a pop star. Look, we need to multiply that by negative 2 to kick him out. Negative times negative is positive, so we have a positive 32. 32 minus 38 is a negative 4. Yeah, it's okay. It'll just, yeah, 8 minus, oh wait, no, I'm wrong. I miscounted. You're right, it was negative 6. I don't know why I said 4. You're right. You're totally right. 100% right. I'm the oops. Okay, negative 38 plus 32 is negative 6. I miswrote that. Good job. I have no clue why I wrote 4. Maybe I was just copying 4 here. Anyways, good job with that. Now, let's do one more problem. Now, this is the trippy one, okay? Fractions. What if there's a fraction in front? And now we're only going to do simple fractions because this is algebra 1. Y is equal to, let me get us a problem real quick. Y is equal to 1/2 of x squared minus 7x minus, let's do 3/2. Okay. Now this problem looks a little bit crazy. Okay. Now I'm going to do exactly what we did before. Ask you this question: what number do we not want? What number do we not want? We don't want what number? We don't want the 1/2, the 7, or the 3/2. If I'm trying to complete the square, we don't want the front number. That's always the case. We don't want that front number. So I want to divide out 1/2 from everyone. Now, this is going to look unintuitive. This is going to look weird, okay? Because if I take a 1/2 off here and I take a 1/2 off here, what happens to the 7? And let me show you. What is 7 divided by 1/2? Do you guys remember how to divide fractions? we don't divide fractions, we multiply instead by the reciprocal. 7 times 2 over 1. We always multiply by the flip fraction. That's a 8th grade math thing. If you're dividing fractions, you multiply by the reciprocal instead. And that's going to be 14. Now, why is that the case? Can I show you guys an example with money? If I use money instead, let's use an easy example. $1. How many halves are in $1? I don't know. 1 times 2 over 1 is 2. There are 2 halves in $1. Now, does that make sense? Why would that be? Let me change this to money. What if this was 50 cents? How many 50 cents are in a dollar? That makes more sense. There are 2 50 cents in $1. If a candy bar is 50 cents and I had $1, how many candy bars could I buy? You could buy 2 candy bars. How many 50 cents, are in $4? How many 50 cents are in $4? There are 8 50 cents in $4. So 4 times 2 over 1 is 8. Because when you're dividing by fractions, you're saying how many of this fraction are in it, and you end up with more. So if I divide this by 2, we end up with x squared minus 14x. Now take a look here. I want you guys to double check it. You should always double check it, especially with fractions. Half of x squared is half x squared, no problem. What is half of 14? Isn't that 7? So you can always double check it to make sure you went the right way. Sometimes you are tricked and you write the wrong number. If you double check it to see if it makes sense, you'll still be in good shape. Now that we've done this half part, now we can complete our square. Y is equal to 1/2. What's the perfect C value we wish we had? So we got to bubble up first before we do a perfect C. Let's double up. Divide by 2. What's half of 14? X minus 7. Okay, x minus 7. What's the perfect C we wish we had? You take 7 and you square it. 7 squared is plus 49 minus 49. Are you always squared to get that perfect C value? We have our perfect complete square there. Now here is the hard part. Be confident in it. Be confident. Thank you. Be confident. 1/2 times 49, put on your jacket to leave the house, is simply negative 49 over 2. Leave it in the fraction form because guess what? We are already in the fraction form here. So it was already set up good to go. I made a mistake here. I shouldn't have copied that. I'm sorry. I messed up. I'm sorry. But we have the 49 over 2 and the 3 over 2. See how the fractions are already set up to good to go? That makes our life even easier. This is negative 49 minus 3 is negative 52 over 2. And we can actually simplify that. 52 over 2 is 26. So 1/2 x minus 7 squared minus 26. And that's our vertex form. Okay, I'm gonna do one more fraction problem for us. Okay, this one looks like it's gonna be hard, but let's go take a look one more time. Y is equal to 1 over 4 x squared minus 5x plus 30. Okay, we're going to go through all our steps that we did before. What number do we not want here? The 1/4, the 5, or the 30? Hopefully you'll say, if I'm completing the square, I don't want the 1/4. Let's take out the 1/4. If we take the 1/4 out, this becomes x squared. Now what happens when I take the 1/4 out of 5? Let's try it. 5 divided by 1/4. That turns out to be multiplying by the reciprocal, 4 over 1. That's going to be 20. Would that make sense? How we end up with 20? How many 1/4s are there in 5? There are 20. So minus 20x. Now, the way we double check here is double check it by, hey, what's 1/4 of 20? What's 20 times 1/4? That becomes 5. Okay, so we can always double check it and make sure you do double check it, especially on these types of SAT type questions. Now that we're set up, we're good to go. Let's go ahead and now we get to complete the square. We haven't started completing the square yet. We've just started setting it up. Just because you're cutting stuff doesn't mean you've started cooking. You just cut up stuff. And what would that value in the inside be? X minus what? What's half of 20? 10. Right, that's we always divide by 2. What's the perfect C value which we had? 10 squared. There should be 100 there, so I'm going to give myself 100 and then minus 100. 1/4 times 100. We're going to multiply, put on your jacket to leave the room. What's 1/4 times 100? That's going to be 25, right? A quarter of 100 is 25 minus 25. Now we can combine our last values. That gives us plus 5. Okay.